Hello friends, welcome. Now today I am going to solve one more problem on non-concurrent force system. I have written the statement. The statement goes like this: determine the magnitude and direction of resultant force for the force system shown in figure and locate the resultant force with respect to point D. So it means we are supposed to locate the resultant with respect to this point D. Okay. This is a figure given in which at A we have an inclined force of 5 kilonewton, which for which they have given a slope 1:2, whereas at B we have a horizontal force which is having a magnitude 4 kilonewton, and exactly in the middle of this rectangle we have 6 kilonewton force either side 1 meter, and a vertical depth of the rectangle is 1.2 meter, whereas at point D we have a couple. It's a couple is nothing but a moment. Okay, when we take a moment about any point, at that time we have to consider this 8 kilonewton. It's not a force, it's a moment. And look at here, the unit for this moment they have given as kilonewton meter. Okay, now I will draw the free body diagram. I have taken this 4 kilonewton acting at B, then 6 kilonewton, whereas this 6 kilonewton is acting from B at a distance of 1 meter, from C again at a distance of 1 meter. This vertical height is 1.2 meter. At C we don't have any force, whereas at D we have a couple. I will show the couple as it is. Then at A we have an inclined force. It has to be resolved. To resolve we need an angle. So let us try to calculate the angle first. So what I do is I will take this angle as theta. If I take this as a triangle, it is 2 and it is 1, whereas I have taken angle as theta. So tan theta is equal to, opposite is 1, base is 2. So theta is equal to tan inverse of 1/2. Tan inverse of 1/2 is 26.56. So theta is equal to 26.56 degree. It's the angle. So whatever the angle which we have calculated, that is with respect to base, means it is with respect to x-axis. So here whatever the angle given for this force is with respect to x-axis. So it is something like this. So this angle and this angle will be same. So I have taken angle for this 5 kilonewton with respect to x. Okay, now angle is given with respect to x. So when I resolve this 5 kilonewton, I need to bring it along x. It is acting towards left. Show the direction toward left, and it is 5 cos of angle is theta, where 26.56. When I bring the same force, because the force is in third quadrant, when I bring it along y-axis, it is acting vertically down. So show the direction vertically down, and it's 5 sine 26.56. Okay, so we resolve all the forces, and this is the point D about which we are supposed to locate the resultant. So let us first calculate summation of H. To calculate summation of H, our sign convention, right side acting force are positive, left side acting force are negative. So summation of H is equal to 4 kilonewton is acting towards right, so plus 4, then minus 5 cos 26.56, and you work out, you will get summation of H is equal to minus 0.472 kilonewton. Make use of a calci and work out, you will get summation of H is minus 0.476. Then to calculate summation of V, our sign convention is upward acting force are positive, downward acting force is negative. So here upward, we don't have any upward acting force, but we have the forces which are acting downwards. 6 minus 5 sine of 26.56. Both are acting downward, so both are minus. So we will work out this one, we will get minus 8.236 kilonewton. Summation of V. We got minus, so we got summation of H as well as summation of V. So here we can easily calculate R, where R is equal to square root of summation of H whole square plus summation of V whole square. So you substitute the value and work out, we will get R as 8.249 kilonewton. To calculate theta is equal to tan inverse of summation of V by summation of H. So theta again work out, you will get 86.72. This is the value of theta. Now after calculating the value of magnitude of resultant and inclination of resultant, we supposed to calculate the position of the resultant. Okay, so to calculate that, we need to calculate small x, small y and small d. So to calculate small x, small y and small d, we need moment about d, because we are supposed to locate the resultant with respect to point d as mentioned in the questions. So let us first calculate moment about d. Take moment of all the forces acting on the system shown in figure about point at this point. So look at here. Well, let us start with this 5 cos 27.56. As a horizontal force, I project the line of action backward. As the line of action of this horizontal component is acting or it is passing through point D, the moment of this is 0. 5 cos 26.56 into 0. As I told that when the line of action of the force passes through the particular point about which we are taking moment, then the moment of the particular force will be 0. Now the vertical component is acting downward. I will show here. Vertical component is acting downward. Okay, with respect to this vertical component, point D is towards right. So draw a line towards right. If this arrow mark follow this path, it is making anti-clockwise movement. So minus 5 sine 26.56 multiplied by the distance. From this line of action, how far is point D? It is about 2 meters. So multiply by 2. Okay, now I have taken the moment of this 2 component. Now we'll take moment of 4. As the 4 kilonewton is acting towards right, with respect to this 4 kilonewton, point D is above or below? It is below. So downward. If this arrow mark follow this path, it will make clockwise or anti-clockwise. It is clockwise movement. So plus 4 into 1.2. As the line of action of this 4 kilonewton is above, is passed through this point C. From C about D it is 1.2 meters. So I multiplied 1.2. Then I have 6. 6 is acting downward. With respect to this 6, the line of action will be somewhere here. From the line of action of this force, point D is towards right or left? It is towards right. So if this arrow mark follow this path shown here, make anti-clockwise movement. So minus 6 into the distance from this 6 kilonewton about D is 1 meter. So it should 1 meter. So 6 into 1. Then we have this couple. Couple is nothing but it is a moment. Already it is a moment because look at here. 4 is a force and the unit of force is kilonewton. We have multiplied the distance. So it is kilonewton meter. Whereas the couple unit, look at here, the couple unit is already in kilonewton meter. So it's already a moment. Whether it is clockwise or anti-clockwise, that we are supposed to look at. So here at a D, we have an anti-clockwise couple. So minus, just write the magnitude. There is no need to multiply distance. Already it is multiplied. Okay. So is equal to 0. You work out this. I will take the help of calci. It is 5 cos 26.56 multiplied by 0. It's already 0. No need to calculate. Okay, then minus 5 sine 26.56 into 2 plus 4 into 1.2 minus 6 into 1 is 6 minus 8. So we'll get 13.67. Its moment about D is minus 13.671 and the unit is kilonewton meter. Now calculate small x. Small is a moment about D divided by summation of V, where minus 13.671 divided by resultant, which is 8.249, which is equal to 1.659. Sorry, summation of V is minus 8.236. Minus 2. It is minus get cancelled. It is plus meter. Then calculate y. To calculate y, it is summation of d, moment about d by summation of h. So we'll get y is equal to 28.964 meter. Similarly, calculate d. D is equal to md by r, which is 1.657 meter.